In futures studies and the history of technology, accelerating change is a perceived increase in the rate of technological change throughout history, which may suggest faster and more profound change in the future, and it may or may not be accompanied by equally profound social and cultural change. While many scholars have suggested accelerating change, the popularity of this theory in modern times is closely associated with various advocates of the technological singularity, including Vernor, Vinge and Kurzweil, among others. Early observations. In 1938, Buckminster Fuller introduced the word ephemeralization to describe the trends of doing more with less, in chemistry, health and other areas of industrial development. In 1946, Fuller published a chart of the discoveries of the chemical elements over time to highlight the development of acceleration in human knowledge acquisition. In 1958, Stanislaw Ulam wrote in reference to a conversation with John von Neumann. One conversation centered on the ever-accelerating progress of technology and changes in the mode of human life, which gives the appearance of approaching some essential singularity in the history of the race beyond which human affairs, as we know them, could not continue. Moravec's Mind Children. In a series of published articles from 1974 to 1979, and then in his 1988 book Mind Children, computer scientist and futurist Hans Moravec generalizes Moore's law to make predictions about the future of artificial life. Moore's law describes an exponential growth pattern in the complexity of integrated semiconductor circuits. Moravec extends this to include technologies from long before the integrated circuit to future forms of technology. Moravec outlines a timeline and a scenario in which robots will evolve into a new series of artificial species, starting around 2030 to 2040. In Robot, Mere Machine to Transcendent Mind, published in 1998, Moravec further considers the implications of evolving robot intelligence, generalizing Moore's law to technologies predating the integrated circuit, and also plotting the exponentially increasing computational power of the brains of animals in evolutionary history. Extrapolating these trends, he speculates about a coming mind fire of rapidly expanding superintelligence similar to the explosion of intelligence predicted by Vinge. James Burke's Connections. In his TV series Connections, and sequels Connections Squared and Connections Cubed, James Burke explores an alternative view of change that rejects the conventional linear and teleological view of historical progress. Burke contends that one cannot consider the development of any particular piece of the modern world in isolation. Rather, the entire gestalt of the modern world is the result of a web of interconnected events, each one consisting of a person or group acting for reasons of their own motivations with no concept of the final, modern result to which the actions of either them or their contemporaries would lead. The interplay of the results of these isolated events is what drives history and innovation, and is also the main focus of the series and its sequels. Burke also explores three corollaries to his initial thesis. The first is that, if history is driven by individuals who act only on what they know at the time, and not because of any idea as to where their actions will eventually lead, then predicting the future course of technological progress is merely conjecture. Therefore, if we are astonished by the connections Burke is able to weave among past events, then we will be equally surprised to what the events of today eventually will lead, especially events we weren't even aware of at the time. The second and third corollaries are explored most in the introductory and concluding episodes, and they represent the downside of an interconnected history. If history progresses because of the synergistic interaction of past events and innovations, then as history does progress, the number of these events and innovations increases. This increase in possible connections causes the process of innovation to not only continue, but to accelerate. Burke poses the question of what happens when this rate of innovation, or more importantly change itself, becomes too much for the average person to handle, and what this means for individual power, liberty, and privacy. Gerald Hawkins' Mind Steps. In his book, Mind Steps to the Cosmos, Gerald S. Hawkins elucidated his notion of mind steps, dramatic and irreversible changes to paradigms or worldviews. He identified 5 distinct mind steps in human history, and the technology that accompanied these new worldviews. The invention of imagery, writing, mathematics, printing, the telescope, rocket, radio, TV, computer. Each one takes the collective mind closer to reality, one stage further along in its understanding of the relation of humans to the cosmos. He noted, the waiting period between the mind steps is getting shorter. One can't help noticing the acceleration. Hawkins' empirical mind step equation quantified this, and gave dates for future mind steps. The date of the next mind step is given as 2021, with 2 more successively closer mind steps, until the limit of the series in 2053. His speculations ventured beyond the technological. The mind steps appear to have certain things in common: a new and unfolding human perspective, related inventions in the area of memes and communications, and a long formulative waiting period before the next mind step comes along. None of the mind steps can be said to have been truly anticipated, and most were resisted at the early stages. In looking to the future, we may equally be caught unawares. We may have to grapple with the presently inconceivable, with mind-stretching discoveries and concepts. Vinge's exponentially accelerating change. The mathematician Vernor Vinge popularized his ideas about exponentially accelerating technological change in the science fiction novel Marooned in Real Time, set in a world of rapidly accelerating progress leading to the emergence of more and more sophisticated technologies, separated by shorter and shorter time intervals, until a point beyond human comprehension is reached. His subsequent Hugo Award-winning novel A Fire Upon the Deep starts with an imaginative description of the evolution of a superintelligence passing through exponentially accelerating developmental stages, ending in a transcendent, almost omnipotent power unfathomable by mere humans. His already mentioned influential 1993 paper on the technological singularity compactly summarizes the basic ideas. Kurzweil's The Law of Accelerating Returns. In his 1999 book The Age of Spiritual Machines, Kurzweil proposed the law of accelerating returns, according to which the rate of change in a wide variety of evolutionary systems tends to increase exponentially. He gave further focus to this issue in a 2001 essay entitled The Law of Accelerating Returns. In it, Kurzweil, after Moravec, argued for extending Moore's law to describe exponential growth of diverse forms of technological progress. Whenever a technology approaches some kind of a barrier, according to Kurzweil, a new technology will be invented to allow us to cross that barrier. He cites numerous past examples of this to substantiate his assertions. He predicts that such paradigm shifts have and will continue to become increasingly common, leading to technological change so rapid and profound it represents a rupture in the fabric of human history. He believes the law of accelerating returns implies that a technological singularity will occur before the end of the 21st century. Around 2045, the essay begins. An analysis of the history of technology shows that technological change is exponential, contrary to the common-sense, intuitive linear view. So we won't experience 100 years of progress in the 21st century, it will be more like 20,000 years of progress. The returns, such as chip speed and cost-effectiveness, also increase exponentially. There's even exponential growth in the rate of exponential growth. Within a few decades, machine intelligence will surpass human intelligence, leading to the singularity, technological change so rapid and profound it represents a rupture in the fabric of human history. The implications include the merger of biological and non-biological intelligence, immortal software-based humans, and ultra-high levels of intelligence that expand outward in the universe at the speed of light. The law of accelerating returns has in many ways altered public perception of Moore's law. It is a common belief that Moore's law makes predictions regarding all forms of technology, when really it only concerns semiconductor circuits. Many futurists still use the term Moore's law to describe ideas like those put forth by Moravec, Kurzweil and others. According to Kurzweil, since the beginning of evolution, more complex life forms have been evolving exponentially faster, with shorter and shorter intervals between the emergence of radically new life forms, such as human beings, who have the capacity to engineer a new trait which replaces relatively blind evolutionary mechanisms of selection for efficiency. By extension, the rate of technical progress amongst humans has also been exponentially increasing. As we discover more effective ways to do things, we also discover more effective ways to learn, i.e., language, numbers, written language, philosophy, scientific method, instruments of observation, tallying devices, mechanical calculators, computers. Each of these major advances in our ability to account for information occur increasingly close together. Already within the past 60 years, life in the industrialized world has changed almost beyond recognition except for living memories from the first half of the 20th century. This pattern will culminate in unimaginable technological progress in the 21st century, leading to a singularity. Kurzweil elaborates on his views in his books The Age of Spiritual Machines and The Singularity as Near. Smart's Transcension Hypothesis. In his 1999 website, and later in Evo Devo Universe 2008, and The Transcension Hypothesis 2011, systems theorist John Smart proposed that both universal and human historical accelerating change are predictable developmental features of the universe. The physical processes that generate Moore's law, related exponential and super-exponential technological change functions, super-exponential phase transitions, and asymptotic domains in mathematical physics are proposed as recent examples of this emerging predictability. In the transcension hypothesis, Smart argues that informational and physical processes of evolution and development drive the universe's most complex systems to use increasingly efficient and dense configurations of space, time, energy, and matter in their computations and metabolisms. At the physical limit, he proposes this developmental process of accelerating change leads inevitably to black hole-level efficiencies and densities, and transcension of advanced intelligence from the physical universe, rather than interstellar expansion, thereby explaining Fermi's paradox. Smart proposes several tests of this hypothesis via future SETI. In this biologically analogous model, the universe, from its galaxies to its myriad civilizations, has been engaging in a process of massively parallel and compartmentalized evolutionary computations and experiments. As in the biological development of multiple evolutionarily unique seeds in an organism's replication process, each emergent civilization may be developmentally destined to package their unique evolutionary learnings for future replication, inheritance, merger and selection with other black hole-like civilizations via transcension. In 2008, Smart and philosopher Clement V. Val formed the Evo Devo Universe research community with 32 other scholars to investigate models of evolution and development at universal scale. A discussion of locality, one example of a potentially developmental system trend that may allow or drive universal accelerating change. A familiar history of accelerating physical complexity begins with universally distributed early matter, leading next to large-scale structure and superclusters, then to the first galaxies, then to metal-rich replicating stars within special galaxies, then to stellar habitable zones, then to prokaryotic life existing on and around single planets in those zones, then to eukaryotic life inhabiting a far more restricted domain of the special planet's surface. then to human civilizations living in yet more localized domains, then to humans in industrial cities emerging as the leading edge in those civilizations, and perhaps soon, to intelligent, self-aware technology, which will have even more unique connectivity, and inhabit, at least initially, a vastly more local subset of Earth's city space. Self-aware computers may themselves be able to enter far more miniaturized and local nanocomputational domains. Thus, to a first approximation, the increasing spatio-temporal locality of leading-edge substrate emergence looks like universal complexity heading toward transcension as it develops. Hypotheses of universal evolution and development remain highly speculative and poorly characterized in our present state of physical and informational theory. For one of the more rigorous proposals of this type, see the model of cosmological natural selection, by physicist Lise Moline. Criticisms. Examples of large human buy-ins into technology include the computer revolution, as well as massive government projects like the Manhattan Project and the Human Genome Project. The foundation organizing the Methuselah Mouse Prize believes aging research could be the subject of such a massive project if substantial progress is made in slowing or reversing cellular aging in mice. Both Theodore Modis and Jonathan Huebner have argued, each from different perspectives, that the rate of technological innovation has not only ceased to rise, but is actually now declining. The validity of their conclusions has been criticized by John Smart. In fact, technological singularity is just one of a few singularities detected through the analysis of a number of characteristics of the world system development. For example, with respect to the world population, world GDP, and some other economic indices. It has been shown that the hyperbolic pattern of the world demographic, economic, cultural, urbanistic, and technological growth could be accounted for by a rather simple mechanism, the nonlinear second-order positive feedback, that was shown long ago to generate precisely the hyperbolic growth, known also as the blow-up regime. In our case, this nonlinear second-order positive feedback looks as follows. More people, more potential inventors, faster technological growth, the carrying capacity of the Earth grows faster, faster population growth, more people, more potential inventors, faster technological growth, and so on. On the other hand, this research has shown that since the 1970s the world system does not develop hyperbolically anymore. Its development diverges more and more from the blow-up regime, and at present it is moving from singularity, rather than toward singularity. Jürgen Schmidhuber calls the singularity omega, referring to Teilhard de Chardin's omega point. For omega equals 2040, he says the series omega-2n human lifetimes roughly matches the most important events in human history. Gallery. Kurzweil created the following graphs to illustrate his beliefs concerning and his justification for his law of accelerating returns. Computer power grows exponentially. Exponential growth in supercomputer power.